Welcome back. Today what I want to do with you is introduce a little bit about acid-base chemistry, chapter 10 in your textbook, in the last chapter in the solutions unit. We're going to go through some review here today of what you may remember in grade 10, maybe a little bit of new stuff, and once again I've tried my best to bring a few chemicals from my own home that I rummaged around the house and found some things, and we'll talk about pH to a certain extent. Starting with milk, some of you may know milk is slightly acidic. The pH of milk is usually a little bit more than 6, and you may remember that a pH of 7 is neutral. On the other hand, soap, which is really hard to come by these days, is slippery. Bases tend to be slippery. The pH of this could be as high as 8 or even 9. So we'll talk more about it. I don't drink Diet Coke, but I found some in my fridge. That is definitely an acid. It involves CO2 and water under pressure, and that makes carbonic acid. So carbonic acid is a weak acid. The pH of this is probably 2.5 or 3, so fairly low, not good for your teeth if you drink a lot of it. Bleach, on the other hand, which is also hard to find these days, this, believe it or not, has a very high pH. It could be as high as 13. And we know that typically the pH scale goes from 0 to 14, but in reality, it can go below 0 and it can go above 14. What I want to do is a classic example of an acid-base reaction. And of course, every young person loves to use vinegar and good old baking soda. And baking soda, remember, is sodium bicarbonate. So I'm going to take a little bit of this and put it into a beaker. And of course, when we add the acid to the base, we can get a pretty quick reaction here known as a neutralization, right? This is a classic example of an acid-base neutralization. Maybe you made a volcano as a kid like I did. It's still fun to do as an adult. So we have acid-base chemistry here. In terms of some theories that go along with it, basically, no pun intended, a base is anything that dissociates into OH minus ions. That is called hydroxide, and the Arrhenius theory of acid-base chemistry kind of determines that a base contains OH minus ions. Potassium hydroxide, if you dissolve it in water, yes, it does ionize very easily into K plus ions and OH minus ions, and the pH of a base is greater than 7. On the other hand, an acid, according to Arrhenius, who was a Swedish chemist, by the way, many years ago, they dissociate into H plus ions. These are called hydronium ions, and they are very, very dangerous in large amounts. That's what makes acids corrosive, by the way. So hydrochloric acid, yes, the same acid that's in your stomach, does ionize very completely into H plus ions and Cl minus ions, and it makes sense that the pH of any acid is less than 7. This acid is way below 7, to be honest. But we can go back to our vinegar. All right, we know we can put vinegar on French fries. Ironically, you're not going to put hydrochloric acid on French fries or sulfuric acid. I actually found my marine battery for my boat. This is full of H2SO4. That's a very strong acid, and you don't want to put that on your French fries. So, acetic acid, on the other hand, a weak acid in vinegar, HC2H3O2, ionizes very slightly into H plus ions and acetate ions. This is a weak acid because there's only a little bit of the H plus present in that acid. Finally, I want to talk about water, because water we know is a universal solvent, and we know that the pH of water is exactly 7. if it's pure water, which by the way is probably impossible to get anywhere on Earth. But in a perfect world, let's assume water would be purified at 7. Well, it just happens to be that H2O is very weakly ionized into equal quantities of H plus ions and OH minus ions. They are equal in concentration. And it turns out that their concentrations end up being about 1/10,000,000th of a mole per liter in pure water. So very little bits of each. That's what gives us the pH of 7 for pure water. So this is a very quick look at what we call Arrhenius acids and bases. Acids contain hydrogen ion, H plus ions. Bases contain hydroxide ions, or OH minus. An acid is strong if it ionizes into H plus to a large extent, and it's weak if it only goes over to H plus to a small extent. This is why we can ingest vinegar, we can ingest citric acid, which is in our citrus fruits, but we cannot ingest battery acid because it's strong. That's it. Our next section, we'll take a closer look at the pH scale itself. We will get our calculators out and use this thing to determine the exact pH of a solution. And we'll also look at other equations that can measure the strength of a basic solution, something called pOH. Until then, hopefully you're doing well, and we'll continue on in our acid-base discussion soon.